In the early days of microgravity research, scientists discovered that protein crystals grown in space are larger and more uniform than those grown on Earth. Since that discovery was made, it became the largest single category of experiments conducted on the International Space Station. The potential of this discovery could help humanity in a variety of ways, such as revolutionizing cancer treatment. In today's video, we will look at how this process works, the variety of ways it could change medicine and technology as we know it. Crystalline structures are any structure of ions, molecules, and atoms held together in an ordered 3D arrangement. Gravity on Earth tends to have a negative impact on the growth of protein crystals due to the convection it causes. Convection strongly influences the growth rate, crystal morphology, and defect formation. The defects cause are significantly detrimental to the properties that scientists are trying to achieve with this crystal. That's why they grow crystals in a microgravity environment, as there is notably less convection, which in turn produces crystals of a higher purity. This optimization of crystal growth could lead to improvements in various fields. On February 21st of this year, a space capsule produced by Varda Space came back to Earth carrying an antiviral drug used in the treatment of HIV. The mission aimed to demonstrate the potential of automated manufacturing of pharmaceuticals in space. During its time in orbit, the capsule successfully crystallized the metastable form 3 of the antiviral drug. They now hope to inspire others to consider the viability of space-grown pharmaceuticals. BioOrbit is another startup excited by the prospect of using microgravity to make immunotherapy, one of the most promising new ways to treat cancer, into something patients can take from the comfort of their own home. Immunotherapy works by mimicking or invoking the body's own immune defenses, weed out and attack cancer cells. But the drugs that do this are typically fed into the blood, using needles in a long and invasive process. It would be much simpler and less painful if the drug could be administered under the skin, but that would require much higher concentrations of the drug, resulting in a thick formula too viscous to inject. That's where crystallization steps in, as you can get a higher concentration into a smaller volume, and a solution of these tiny crystals comes without all the viscosity. Lambda Vision has had 8 experiments conducted on their protein-based artificial retina. Manufacturing the retina involves depositing 200 paper-thin layers of light-sensitive protein into a polymer mesh. These layers must be perfectly even for the retina to work, a process that is hard to get right on Earth. The International Space Station experiments have improved the production of the artificial retina dramatically by producing nice even layers with less wasted material. Not only does microgravity crystal have great implications for medicine, it will also be able to help with the innovation of semiconductors. Semiconducting materials are vital for all kinds of electronic technologies, but their manufacturing on Earth is costly and energy intensive. There is ongoing research into developing silicon carbide semiconductors, which could be used in harsh conditions like space. Silicon carbide is also a naturally occurring, abundant mineral that is present in Martian soil and lunar regolith, meaning this technology will play a vital role in an interplanetary civilization. Another form of technology being produced is ZBLAN, glass alloy optical fibers. ZBLAN drawn into fibers on the ground form crystals that scatter signals and make the fiber brittle. In microgravity, the approach is to cool drawn fibers before crystals can form. ZBLAN's unique properties allow light to travel through a fiber over a broader range, providing more than 10 times the capacity and transmitting considerably more data over the same length of traditional silica-based fiber. It could allow the planet's available data throughput infrastructure to grow at a faster pace, ensuring the world could stay connected as the number of internet users and internet-enabled devices continues to grow exponentially. This new phase of space industry has only just begun, and the possibility it brings to help humanity in many ways is very exciting. Through medicine and technology, microgravity crystallization is set to change the world. What I've told you about today is just a small piece of the pie of the possible advancements this discovery holds. If you found this video interesting, make sure to like and subscribe. And then also, if you find the future of space technology interesting, make sure to check out this playlist. Thanks for watching.